Today is a major milestone because we are moving beyond vanilla large language models and stepping into the world of LLM reasoning. Think back to the standard pipeline. First is pre-training, where the model learns language and code by predicting the next token. Second is supervised fine-tuning, where it learns to behave like an assistant. Third is preference tuning, where reinforcement learning with human feedback aligns it with human values. Even after all this, there's still a major limitation. The model is a System 1 thinker. It predicts quickly, but it does not think before it speaks. This works well for writing or summarization, but it often fails at math and logic. To solve this, we define reasoning as solving non-trivial problems using multiple steps. For example, answering a direct question is simple, but calculating the age of something based on years requires understanding and step-by-step thinking. This leads to chain of thought. Instead of giving a final answer immediately, the model generates intermediate steps. By producing more tokens, the model gets more compute and breaks the problem into smaller parts it understands. You may have seen this as a thinking phase before the final answer. This is not just for display, it improves accuracy. However, prompting alone does not scale. We cannot manually create reasoning examples for everything, so we use reinforcement learning. Instead of telling the model how to think, we give it a goal. Reasoning tasks help because they are verifiable. In coding, the program either works or it does not. In math, the answer is either correct or wrong. The model generates multiple solutions and learns from which ones succeed. To measure this, we use benchmarks like HumanEval for coding and AME for math. Since models are probabilistic, one attempt may fail, so we use pass at K. This measures the chance that at least one out of multiple attempts is correct. This is the shift to the reasoning era. Models are moving from generating text to solving problems step by step.